So when we look at typical job markets, job roles, typical roles in the job market when it comes to the entry-level engineers, usually there are three broad streams which are available in this industry: at the hardware level, software level, and simulation and system engineering level. This is apart from the roles which are available in the mechanical industry. For example, a mechanical engineering team again could have varied roles like a battery packaging engineer, thermal simulation engineer, and so on. That's not within the purview of this particular webinar. So in this particular webinar, I'll give you an overview of the kind of jobs which are available for electronics hardware design, embedded software design, and simulation engineering. On the hardware design, whenever you are joining fresh out of college, you will usually join as a graduate engineer trainee or a postgraduate engineer trainee, depending on the qualification that you have, and you will be mostly into embedded system hardware design. So for the first 1 or 2 years, you will be mostly testing most of the modules, because directly getting into automotive hardware design is very tough, because you need to understand the system even before you design them. So that's where you will spend majority of your time for the first 2 years, trying to understand how the system behaves, trying to understand existing electronics, how they have been designed and why they have been designed. So this is the job of a design engineer at entry level. There are also various roles on the design verification. So you can be a purely testing engineer, where you will understand how to test an electronics based system, or how to test an electronic PCB. So what are the different things that one must know while doing a board, something we call as a board bring up for PCBA, that is printed circuit board assembly. So what are the various ways of testing it? For example, manual testing. How do you do an automated testing, and why? What are the pros and cons of each approaches? This is something you will explore in the first initial years of your career. The other specialization in hardware could be a purely power electronics engineer, where you are again in the first initial days of your career, you will spend time trying to understand different converter topologies which are available, switching circuits, for instance, advanced switching circuits for MOSFETs, IGBTs. What are the different types of power converters available? Most likely, you will spend time trying to correlate your academic learning with the practical implementation, trying to understand from theory and from a practical perspective how things are converging, and you will be able to appreciate in the initial years of your career. Coming to the software, three major roles are available. One is the base software engineer, or an engineer who will write device drivers for all embedded system printed circuit boards which are available. So base software engineer more or less is like a generic or a generalist who has nothing to do very specific with the vehicle per se, but he's more interested in the device level. For example, SPI communication, UART, I2C communication. So he's more interested into the protocols and how to code in order to make the devices communicate with each other over different protocols. A middleware engineer is someone who is trying to you know, establish a link between the base software and the application layer. The application layer is the software which actually consists of the the core algorithms, for example, SOC, or plant model of the battery, and so on. So a middleware engineer usually uh, designs the adapter, plug-in adapter between the base software and the application engineer. So why this middleware is engineer's role is very important is to ensure that the software we develop either at the BSW level or at the application level are completely decoupled from each other if it has to be reused for other applications. He ensures that there is a plug and play kind of an approach possible between the BSW and the ASW application software. This role also calls for understanding various standards which are available for developing interface adapters. Last but not the least, simulation and system engineering is also something which is very upcoming and very interesting role within electric vehicle space. A simulation engineer is mostly his job is to understand HIL, MIL, and SIL testing. model in the loop, software in the loop, and hardware in the loop. In the initial years of one's career, one may be trying to explore what are the different hardware elements available in the HIL system. For example, he may get a hands-on on LabVIEW or DSpace, and also different hardware modules which are available in LabVIEW and DSpace, and how to make a basic HIL setup for any PCBA. So similar, same thing holds good for model in the loop and software in the loop, where initial years you will try to explore the different types of battery models already available, how to make your own model, how to refine the model, and run the model and make it correlate with the experimental data. So these are some things which you will learn as you go on as you progress in your career. System integration is more to do with the vehicle level integration of the battery pack or the power electronics with the vehicle. So where you will deal with how to connect various electric vehicle subsystem components within the vehicle, what kind of wire harnesses have to be used, what are the different standards which are used to select cables, connectors, different system components like contactors, relays, fuses, recharge resistors, etc. And also, a person working in system integration will get a hands-on on what happens really at a vehicle homologation requirement. Means when the vehicle is taken to a regulatory authority to get it certified, what are the things required, what has to be made ready before the vehicle is shipped to the government agency, and so on. So if you see the typical roles which are available in the senior level, is mostly that of design, uh, hardware lead or a hardware designer who is not now into a detailed design, but uh, because his view of the system now has increased and he has increased responsibilities, he will make the hardware architecture, DFMEA. He will negotiate the CFT reviews and also work for reliability prediction of electronics. So the detailed design will now be done by the entry to mid-level engineers, and he will oversee the entire operations of the hardware as well as look at advanced opportunities or advanced tools and methods to make the hardware more robust. That's where the DFMEA or DRBFM comes into picture. The same thing good for a design verification engineer now. He will be a design verification lead engineer who will command a set of uh, uh, entry and mid-level engineers to come up with innovative ways of testing the hardware for both mechanical, electrical, as well as environmental tests. A power electronics lead will mostly look at the advanced power conversion topologies which are available, the how to increase the efficiency of the different power converters which are available in the design, and different new devices which are coming into the market, and whether it really makes sense from a business perspective to have devices into the new design or not. Again, it's a very tricky role because technology is advancing at a very fast pace, and everything which is available in the market may not suit the market. So there will be a lot of advancements, but implementation again depends on how the customer uses the vehicle or different use cases within a particular geographic area and so on. Coming to the software, typical design leads, typical roles are again that of a design lead, middleware engineer lead, and senior application engineer lead. These are again team leads who are trying to, who will be assigned with a bunch of engineers who will be doing the basic day-to-day activities that we talked in the previous slide. But the leads are again interested with additional responsibilities of defining the software architecture, ensuring that the software architecture is truly layered, and coming up with state machine designs for different algorithms, and developing different APIs in an efficient manner so as to ensure that the same APIs can be reused in multiple projects. Then model-based design is something which has very increasing relevance in the industry because the manual coding is becoming quite obsolete. People are looking at developing models using MATLAB Simulink and then directly porting it to the embedded device. So this is where the software senior application engineer will start looking at what is the loading which is happening because of using such an approach. What is the permissible load? What is the RAM consumption, flash consumption? What is the amount of extra load that the CPU can take? Function partitioning, for example, a detailed look into the timing of different functions, etc. So it's a very complex job, to put it in a nutshell. Simulation and system engineering, again here, a simulation lead will be responsible for uh, enter end-to-end test system development for the mill cylinder. The system lead now will be responsible for one full vehicle program. So a particular vehicle program end-to-end, right from requirements engineering, customer facing, component selection, coordinating with different members of his team and assigning different roles or different design responsibilities to different team members, and reviews, etc. The day-to-day activities of a system lead. So when you see typical job roles which are available in the top management, usually most R&D centers are headed by chief technology officer, whose major contribution will be in terms of future technology, bringing in robust practices, something called as a continuous improvement process (CIP), and developing a mission and vision for an R&D center. Also looking at future technologies where some groundwork can start much ahead of what the market demands. On the hardware, mostly it is DGM who will be looking after the program management and customer facing. So purely it's a management role, but he should have a sound technical exposure on battery management system. Subject matter expert who is a hardware design expert who will review designs and proposals, also review different new technology introduction and new product initiation proposals, who will draw the technology roadmap for the entire R&D. What kind of devices have to be used, what different kind of products which we have to deliver or develop to cater to the different market needs. Similar roles are available, applicable for software as well. There is a DGM who will look after the entire software part of the program management. So the entire base software, ASW, customer facing, everything comes under DGM. Apart from that, he can also play a cross-functional role. He can liaison for some vehicle tests. So sometimes the subject matter expert and the DGM themselves participate in vehicle level trials with the customer, because they have a higher knowledge at the system level as well as when handling OEMs. It's not about technology and engineering, because DGMs also come with a lot of management experience. They may have a professional education attached to their career as well. For example, they may have an executive MBA from an IIM or a top one business school, which will also help them to, which also gives them an edge over others on how to deal with customers, how to take them along in the design journey, and how to address different customer needs. So this is one of their specializations as well. Coming to the simulation and system engineering, the DGM for simulation engineering will ensure that the entire test system development for the R&D will be set up by his team. And since this is a test infrastructure, it needs time to time upgradation of the infrastructure, and also looking at advanced test methodologies to make testing easier, point number one, and to make testing times as short as possible, because especially in electric vehicles, the number of test cases for each subassembly is quite huge, very, very huge, because there are a lot of parameters to consider. So the number of permutation combinations run into massive figures. So it's very important to have or test use cases which are only relevant. So it doesn't make sense to test 1 million cases, out of which only, let's say, 10,000 cases are relevant and others are don't even occur. So that's where different test methodologies are very important. System, again, there can be a DGM who can take the entire system engineering under his purview. So all the vehicle programs will come under the system engineering head. So he will be having a bunch of system leads under him who will be responsible for individual vehicle programs, deliverables with respect to each vehicle program. And again, he will be the one who will be facing the end customer on the vehicle homologation requirements, etc. So just to take you all through the case study, for example, in system engineering, what happens typically something like this. System engineer comes up with a block diagram for the entire system, how the onboard charger is connected to the BMS, or how a fast charger can interact with the BMS, how the CAN messages between the different electronic control units will be exchanged during the vehicle operation, vehicle idle, as well as during special vehicle scenarios. For example, what happens whenever there is an accident, how the ABS sensor is going to communicate with the BMS to help the BMS to open the contactors of the vehicle and ensure that the occupants are safe. What is the reaction time for this to happen? For example, the time to the moment the accident happens to the point where the contactors open, what is the time taken. So these are all the kind of use case scenarios that a system engineering professional will be well versed, and it's also something which forms an integral part of his work, being be it at entry level, mid level, or senior level. So this is something very very important, and also has a lot of demand and relevance in the industry. When it comes to hardware engineering, the typical activities will revolve around three things. One is creating the hardware architecture. This is something on the left hand side that you can look at. This is block diagram, how the hardware will be connected to the cells and what are the different functions which are available. A detailed design, which is the middle image, which shows the low level design in which uses integrated circuits, resistors, MOSFETs, IGBTs. So it's a detailed design. And the third one is CAD engineering, which means PCB layout, design of PCBs, and mechanical packaging, which of course I have not shown in this figure. So the fourth component is how to integrate your PCB with the mechanical module, because finally the PCB has to sit inside a vehicle. So are there enough clearances? Is the PCB experiencing any fouling, any component touching the PCB? What are the effects of electrical shock and so on. So that's another part of hardware engineering, very very niche area. Very very few engineers are available at the moment in India. So this is also something where a lot of demand and growth is expected in the coming years, because unlike conventional powertrain in EV space, India is looking at a lot of localization and local talent. So hardware engineering is also one of the very bright avenues for most of the students aspiring to have a career in the EV industry. The second one is a software engineering, where broadly it can be at the application software level. On the right hand side figure, you will see the interaction between various software components. So you can see that there are a lot of control strategies, control loops which are available in the software, and different set point values. What is the kind of action that the ECU has to take? All these are defined in the application software. So the left side shows the function partitioning. If you have a battery pack, what are the major functions that it can do? So it's a function tree, which basically gives how the interaction is between the different components. So coming to the requisite skills for the industry for hardware, what is really required is a good knowledge of analog and digital circuit design and power electronic devices. On the simulation front, one needs to have a good knowledge on PSpice, LT-Spice, ORCAD capture, and Ultim Designer. At least PSpice, LT-Spice, and ORCAD is widely used in the industry. So LT-Spice again is available free of cost, so you can make use of available free versions of LT-Spice to get a hands-on of how to do simulation, circuit simulation. Software, good knowledge of device drivers is expected. So students already have exposure to various open source platforms like Arduino and Raspberry Pi. It's good to get into the details of the drivers rather than just using them how they are available. So this is something which has very very high demand in the market, device drivers, and the number of engineers available also is very very limited as compared to application software or middleware engineers. Device drivers, because it requires a totally different understanding at the device level. So you need to understand the data sheet of the devices that you are trying to talk to. So you need to go line by line into the data sheet, understand the protocol, understand the electrical parameters, etc. So this is a very very challenging role and limited opportunities, but very good opportunities exist in this domain. In the coming years, the need for this will just explode, because there are huge number of complex devices which are coming into the electric vehicle. So very important to have this. Communication protocols, for example, CAN, understanding the different standards of CAN, J1939, ISO 11898. This is also a very, very important field, because this is something like it's going to exist for years. CAN has been there for a long, long time, and it will continue to exist because of its proven nature of use in different vehicles. It's really bulletproof, so it's going to exist in the automotive industry for quite long. So having a hands-on in the different types of CAN protocols which are available, like AEJ 1939, ISO 11898, or what exactly the CAN physical layer demands, what it takes to connect, for example, 100 different CAN nodes at the system level, hardware level, as well as the software level. All these things have a lot of demand in the market, and also very interesting in terms of how the communication protocol itself has been designed. So on the coding area of coding, embedded C is something which continues to be used. Again, knowing the different coding guidelines and standards, code generation using MATLAB, Simulink, model-based design, having a hands-on on vector tools for or CAN tools, for example, Cano Canalizer, or for example, Busmaster. Busmaster is a free tool which is available from Bosch, so you can use to analyze CAN messages and so on. So again, this area is also having a lot of demand. Simulation and system engineering. Currently, this space has very few experts because it requires very complex understanding of the system and a good overview of the vehicle, as well as it requires a good overview of everything: hardware, software, the way the batteries behave individually and when they are stacked and made into a module. It is a multidisciplinary field. So if you start trying to build skills in this area, I'm sure you are going to find a lot of opportunities in this area which are very unique. You may not have uh, too many engineers in this area because it's a very niche area. Again, like hardware, system engineering also is a very niche area. Not all may get an opportunity to pursue system engineering and hardware.